Good afternoon. People are starting to come into the stream. I'm not sure if I should wait, if they can identify themselves. Oh wow, look, everyone's coming on time. If you have any questions, you can put them in the chat at this point. But otherwise, I'm just going to solve the problems in this old midterm. Are there any problems in particular? Hi, Heike. Any problems in particular you'd like me to discuss? Relevant to this or in this old midterm. Hi, Jan, Chloe. So are there any of these questions that you prefer over the others? I had a request to look at the problems with the outliers. So I could start there and then go from the beginning to the end. How does that sound? So I figured out my technical difficulties from yesterday were mostly that I need to charge all of my devices or they're just going to run out of battery. Okay, so let's see. Let's look at the outlier problems first. So that would include, okay, so let's see. Let's look at number 11. How many of you actually solved the exam already? And how did you do if you solved it? It's a lot of information. You could share it in the chat. So for this problem, number 11, the number of speeding tickets given by a sample of 20 police officers over the course of a month are ordered and shown below. The 5-number summary for this data is given, and you have to find the corresponding plot. Should I give you some time? I'll give you 2 minutes. I was warned I can't play music during the stream or I might get a copyright strike, which would be obnoxious. So that's why a lot of YouTubers create their own music or they hire people to create music for them. So I can't put music on, but maybe you can put music on where you are, and I'll give you 2 minutes to try and solve 11. Okay? Hola, Isaac. We're solving this problem. I'm giving the students a few minutes. So if you can identify it or if you can read it, it's in the old exam I noted in the description of the video. Okay, so what you should notice is first that the data is in order, so it's already been ranked, and you've also got the 5-number summary. So what you have is you have Q1 and you have Q3. So you can create the range outside of which outliers exist. Okay, so we would use the 1.5 times IQR rule to determine that range. So you can do it in both directions. It's harmless, but it looks like, well, from 80 to 125, it's like 45, sorry, 45. That's about the same distance as that. So let's find the right box plot. So they're demonstrating that all the box plots in the interior are the same, you see? So there's more of a skew in the middle, 50% towards the left. However, let's just calculate the thresholds. Remember how you do that? So first you get IQR. Right? So IQR is 80 minus 60. It's 80 minus 60, so it's 40. And then you're going to multiply that by 1.5, and you'll subtract it from 60 on this side and add it to 80 on this side. So 40 times, oh sorry, 40, not 40, 20. Look at that. This delay. So IQR is 80 minus 60, or 40. 40 again. 20. So it's 20 times 1.5, right? It's 30. So IQR times 1.5 is 30. So what I'm going to do then is subtract that from Q1 and identify in the range of values up here where that threshold is. So let's see. 60 minus so just to say the rule, where am I going to put it? So 1.5 times IQR, you subtract that, so you go 60 minus that, and then you use it on the other extreme, you say 80 plus that. So 60 minus 30 is going to be 30. So that's going to be where that will be in here, right? And then 80 plus 30 is 110, and that will be here. And so those are the values that are not included. Okay, so 60 minus 30 is going to be 30, and that's there. And 80 plus 30 is equal to 110. And so it's here. All right, so what do you guys, okay. Hi, Didia. Right, Chloe. So outliers are outside the range of 30 and 110. So which one is it? Which one looks like it? So what do you pick? A through E, which one is the best option? No, it is. It's just for two values, right? So it's just 2 and 2. So it's either this one or this one. And that's it. It can't be the other one. So it's either A or B. So all you have to figure out is the cutoff here. So which one is 30? It should be B. Right. Maria, it's B. Very good. So the answer is B. How was that? Did you learn something? All right. So, is that good for that? Who was it who was asking me to do these outlier problems? Let me confirm who wrote me. Anyway, somebody asked me. Okay. So is that okay, Maria? Should I do another one? The lines are the range. Yeah. The lines represent these values. Okay, so that's the extent, the whisker. It's called the whisker of the box. The whisker of the box. So it goes between 30 and 110. So this is it. And these are the numbers 20, 23, and these are more spread out because it's 115 and 125 on that side. Okay, very good. All right, so let's start from the top then. Maybe I'll ask you, well, I don't know. I guess I'll just have to pick some because there's no way I can do the whole exam, right? So go back, watch the videos that I made. All this stuff is in there. But these are just practicing those concepts. So now that you understand it better, maybe you can go back and review. Okay, so we don't have to do number 1, because we did something like that the other day. Let's try number 2. We did 3 and 4, so let's try number 2. Okay, so let me leave you for 2 minutes, and like I said, play some music to keep yourself calm and try and solve, or at least attempt number 2, and I'll be back. So you should realize this is a weighted mean problem. I provided videos for the concept of weighted mean given different sets of information, and this would be the case where you're given here the frequency of observations that share the same midterm score. And so you can use that, since you've been given the average overall, you can use that frequency formula to get the answer. Oh, you guys are seeing my text? I don't know how you're seeing that, but oh my god. I don't know how to turn that off. Amateur. What if I turn that off? Okay, so what we're going to do is set up a calculation let me just confirm what page this is on. This is in GDS, and it's the weighted means. If my computers crash again, just hold out and I'll reboot them. I'm asking them to do a lot right now. Okay, so these are the formulas on page 23, 24 of the notes. So this is GDS pages 23 and 24. So what you have to do is you have to multiply each of these and then sum them. you're going to sum them, and then the total should equal what? It should equal the average that they mention here, the overall average, and something else. Because what I'm supposed to do is I'm supposed to multiply these, multiply the frequency times the mean, plus the frequency times the mean, plus the frequency times the mean, and then average all of that. I need to average all of that for how many students? Oh, right, okay, it doesn't say. That's what I gotta figure out. Right. Right. Maybe I'm doing this wrong. Let me think. Essentially, what you got to think about is that what is the mean, right? So we have this formula that I talk about. Right? So you have here the you see, you guys are talking to me. You guys are talking to me and I don't see it in my other feed, but okay. I can see it now. Okay. So what you have here is the mean. You have the sum, and then you have this n, the sample size, which creates the average. So think about this as the total. So it's the total divided by the sample size equals the mean, right? So what you're going to do, what you're doing is converting all of these things into totals. And so if you compute if you multiply these two, you get the total score, like all the points, right? For the students, and then you get the total for A3, but A2, what can we do? Well, we can just put there something to mark it, which is not a big deal because we can just call it N, right? And then we can also put the N here. And we're basically solving a problem. I don't really want to wipe this out, but okay, let me write it below and then I'll move it up. Or maybe are you guys solving it? Are you working on this? I hope so. Okay, blank page. So in the blank page, we're going to write 150 . So 150 times 68.8 plus n times 61.6 plus 140 times 71.4, and that equals oh my goodness, I lost it. Gotta go back. That equals 67.73 times n. So you have a very long, messy equation, but this is how you're going to solve for n. Solve for n from that, and that should give you your answer. Can I leave that with you? Or do you want me to finish it? Want to finish it? I don't want to make any mistakes. Let's see. It's going to be 150 times 68.8. There's probably an easier way that I'm missing out on. Oops. 150 times 68.8 is 10,320 plus n 61.6 plus 140 times 71.4 equals, wow, these are big numbers. 140 times 71.4 I'm here, I'm just calculating. 71.4 is 9996, and this should equal 6 or n 67.73. So bring your terms together, this one and then this one over here, and you can find n. It's very messy, but you can do it. That's the most immediate way to solve this problem. So as I mentioned, for the midterm, you should work on separate pages and upload those within 10 minutes of finishing the exam. Okay, that's what I want, so I can see your work for part marks. So that's if you get the answer wrong, I don't have to give you 0 out of 2. I can give you some part marks. So each question will be out of 2 points. Alright, so if I subtract 9996 from 10,320, I get 324. I hope you can see that. I think we're running out of space. There you go. And I'm going to take 67.73 minus 61.6 for 6, well, n times 6.13. Let's see if I didn't make a mistake. Anybody can confirm my calculations? Let's see if n then is equal to, let me fix my n, getting better. I found kind of a stylus to work with. Okay, so n is equal to oh, it doesn't look right. Okay, let's see, let's go back a bit. 150 68. So you get to see as I'm calculating. These things aren't so straightforward, right? You got to do some calculations, some grunt work. Oh, why did I subtract them? That's silly. 10, 320 equals. So I have to erase this. No. No. This is an error. Okay. So I have to add those. And then divide by 6.13 equals. No, that didn't work either. So 10, 320 plus 9996. Yeah, I made a mistake. I shouldn't subtract. Oh no. Too many things to think about doing this. 20. Very distracted by my penmanship. How's that? Better? So basically, if I clean this up a bit, I don't want to erase the whole thing. How you doing? So I added those, and then I subtracted. Then I subtracted this minus this, because this is on this side and I want to subtract both sides by this amount. So you put the ends together, and that's 6.13. So in the end, I'm calculating 2316 divided by 6.13, and I get a very large n. And I'm still not done because I got to go back to the problem. Oh, we got different ends. Did you do what I did, Chloe? I get a different n. 10, 320 plus 9996 divided by 6.13. Anybody else got a number? 8 of you watching. Someone should make the calculation. Oh, maybe because 71.4, did I do that right? 140 times 71.4. Yeah, that's right. There's that dot there. Anybody else got a number other than Chloe? 2316 divided by 6.13 gives, well, I get 3314.19, which is, it really should be a whole number, so I don't know why that's happening. That is not correct. So something went wrong. What did I do wrong? 150. Sorry, guys. 150 times 68.8 n times 61.6 and 140 times 71.4 should be 67.73 times the total. Oh, that's why. That's not n. That's got to be, that's my mistake. Oh my gosh. Okay, so let me fix that. It's very easy on here because I'm just going to go like, I lost everything. One back. So what happened is when we did n, when we calculated n, it should be for the n of the total, not just the n of section 2. So that didn't make sense. So let's do this right. So this should be the total. This should be 67. Oh my goodness. 67.73 times n plus the other classes. So that's 290. Now that's going to make sense. And that's going to work. And when you solve this, because I'm going to let you do it, when you solve this, you should find that n is equal to 110. Now, some people would just forget about doing the algebra and just plug in all the alternatives. I've known students to do that. It's quite clever. Rather than doing all this in that time, you could have easily just plugged in the different numbers to this equation rather than solving the algebra, right? So if you put 110 on either side, if you put 110 in here, that should equal the other side with 110 in there. Or you can solve it algebraically. Does that make sense? I hope so. Hope I didn't completely confuse you. But you can see that you shouldn't know the answer automatically. You got to make an equation and you got to get down to it by using first principles. This is just a weighted mean. Okay, and I used the idea of the mean and calculated the total score, all the points for all the students. Well, the average times the total students. So that's really the total points is what it is. Are you guys doing it? So this is going to be just going to confirm. You could use Excel. That would be faster. If you know how to use Excel. If you're plugging this into your calculator, you can use brackets. And that is the right answer. Okay, so that's the equation you want to work with. How do we solve the equation? 67.7? 67.7? What do you mean, how do you solve the equation? You can just, okay, if you want to see me solve that, I can do that. If you want to see that. I'll erase this stuff, the answer. All right, so I'll figure it out here. So putting these together, just like we did before, right? You're going to put together these two, and then there's going to be one over here. So you're going to multiply this to that and that to that. It's called, in English, you say FOIL or distribute, right? In Spanish. So you would do 150 times 68.8 would be, I'll shrink this. So this is going to be, these numbers look familiar. 320, and then 140 times 71.4 is 9996. And then on the other side, you're going to have the ends. So we'll put the ends on the other side. That will be 67.73 N. And then the one from this side over here, we got to put it over on this side. So you're going to subtract both sides by 61.6 N. So you're going to put that over here. And then you're going to put this amount. Okay, I'm kind of jumping, but you can see I'm just grouping. It's like you're organizing your closet and you're putting all your socks together, or you're putting all your tops together and you're putting all your jackets together. Okay, we're just grouping together. So these are numbers and these are ends. These are constants. So the one that's missing is this one here. So 67.73 times 290 is a very big number. So I think I got everything there, right? So now put these together and sum these together and make the division, and you'll see you get 110. Is that all right? yn plus 20. Okay, yn plus 290, because n, if you recall, n was the unknown here that we're trying to solve. Okay, so what we're doing is the weighted average. It's this times this, plus this times this, plus this times this, all divided by the total, like these here. The total here is 290 plus n. So that's why I'm doing that. So the total students is 290 plus n. Okay. So that's where that comes from. Okay, so work with that. Let me know if you have questions. Okay, just refer to this problem as question 2. And it took a long time. We practiced many things. It looks like it's a very long problem, but it doesn't have to be. It's just that I'm using a stylus and making mistakes. But that's an exercise to practice the weighted average. Let's do another one. Let me just finish this by saying, if you solve this, it's almost 40,000 on one side, and the other side is that number from before. This is an example of why you want to send me your work, because you're going to work hard and maybe get the wrong answer, but at least I'll see your work and I'll give you maybe 1.5 points out of 2. I appreciate that because I make silly mistakes too. But you know, you have the advantage, you can use Excel. You can use Excel to try and get the answers as well. Oh my goodness, is this supposed to be a negative? Again, a mistake. Ugh, it's so awkward doing this. Nope, this should be a minus here. Why is it a minus? Because I brought it to the other side. Now it'll work. Oh my God. So many mistakes. I need to prepare these in advance. Okay. That makes more sense. Yeah, because this should just be 60 or 600 or something. Okay, so this would be 10,320 plus 9996 minus 19,641.7. Yeah, 674, right? That's, and then divided by 6.13. Yeah, times 674. Okay, so yeah, it works. I'm doing more than I should. So keep in mind this is a minus here. So you can practice that. Or you're going to see other exercises that are similar. Once you do one of these exams, you'll see the other ones are similar. And that way there's no real surprises if you do all the problems. So n is 110. Okay. Sorry for all the errors. Did you get the answer, Heike? N is 110 because n is equal to 6743 divided by 6.13, which is 110. Yes, very good, Heike. So what some of the students did, you didn't have to go all the way, right? You could just show the expression that was above here, and just as long as you make that expression, then you just plug in the alternatives. You don't have to actually solve it algebraically. All right? So that's the key way. I just did this extra because some people wanted to know how to do the algebra, and it obviously takes a long time. Okay, so done with that. Practice. Review the video if you get a chance. And let's do something else. We did 3 and 4. Well, we did 3 yesterday. Did we do 4? It's hard to do because I have to flip between pages. Quartile of exam scores. Okay, so which interval? So these intervals are going by tens. Which one has the first quartile? That's the question. What's the quartile? Which one has the first quartile? The quartile is the first 25% of the observations. So how many observations are there? There are 127, right? It's 127, and what's 25% of that? Like, how many observations would be in the first quartile, in other words? So then you can use the frequencies to find the first 25%. Okay, so 25% is like, it's really a quarter, right? 25% is the same as 0.25. It's also the same as 1/4. So you could say a quarter of 127 is how many observations? Can you see that? So 127 divided by 4. You guys, if you know how to use the speed button on this, that will speed you through my corrections and errors, okay? And when you review this, also you can, I'm going to put the timestamps in. I put the timestamps in on the other videos. All right, so 1/4 of the observations, 127 divided by 4, is 31.75. So where is the 31.75 observation? Well, if you count through them, you can do what's like a frequency total. So you can sum as you go along. Let's make this bigger, actually. Let's make this bigger. So you can go across and say this is 3, and this is 9, and then this is 20. So these are totals, right? So this is called cumulative or totals. All right, so total or cumulative. I don't have room to write it, but you know what I'm doing. So I'm just adding. I'm adding. Once I get there, there's 3. Once I'm here, I've seen 9 observations. Once I'm here, I've seen 9 plus 11 is 20 observations. Once I'm here, I've seen 36. Okay, so there, I crossed the threshold of 31. 31.75. Need to make this much smaller. Okay, so between, in this class, of this interval, you're going to find the 31st observation and the 32nd observation. So 60 to 70 would be the answer. Let me confirm. Yep, the answer is therefore D. Okay, it's going to be, this interval contains the 31st, 32nd observation. Questions? Remember, quartiles refer to 25% of the observations. The first quarter is the first 25%. And by using this cumulative, we see here there are 3 observations. There's a total of 9. That makes a total of 20. And that's 36. All right. So this position, this class will mark below that are 25% of the observations. You see there's much more over here, so 75% of the observations are above it. All right, let's see what else before we go. If you have any questions, let me know. Box plots. Okay, so I have a lot of videos on how to analyze box plots. If you have trouble with 5 and 6, let me know. I'm gonna skip those. All right, number 7. Number 7. The noon hour temperature in San Lorenzo each day for 1 week in July are shown below. What is the median noon hour temperature? So how do I use this depiction of the data to calculate the median? Remember, what is the median? The median is the middle observation. The median is the 50th percentile. 50% of observations are below it in a rank ordered set of observations. So what you're seeing here in the display in this graph is on Sunday there's 20. The temperature was 20 degrees. On Monday the temperature was between 15 and 20. And Tuesday it's 25. So this is a graph, and from the graph you can extract the data, and with the data then you can calculate the median. Don't be misled in the presentation of the data. It's not, I have here along this axis, I have along this axis just different days of the week. If this was a histogram, I would have the values along this axis. Okay, so this is not to be misconstrued as some sort of histogram and this is like a density curve. That's not what's happening here. This is just a time plot of the data. So you could extract the data and calculate the median. You can do it in order or taking the values out. So this one would be 20. So 20 is one of them, and then something between 20 and 15 and 20 we can say, we're going to say it's 16, and then the next one is 25, and the next one is 30, and the next one is 26. I'm estimating, which is fine. I'm going to get the right answer approximately. 26, and if you want to say it's 27, let's say it's 27. 27. And then this one is closer to 15, and this one is 17.5. And now take those and put them in order, and what's in the middle, that's the issue. So you put them in order. The smallest one is going to be 15, right? And then you can even use the chart to pick them up. The next one is this one, which I'll say is 16, or I could say 17 or 16, because that's what I wrote before. And then the next one is here, it's a little bit higher, we'll say it's 17.5. And then the next one is here, no, here, 20. And then the next one is here, 25. And then 27.5. And then 30. Okay, so you can do it either by just reading from left to right or go by height, but eventually you have to have them ranked in order. So we'll use this list of ranking them. Oops. I'm trying to erase this one. Oh well, I'll leave it for now. So then they're in order, and the middle, there's 1, 2, 3, 4, 5, 6, 7, right? Because it's the whole week observations. And the middle, since it's an odd number, there is a direct middle. And so the middle is 20. And you wouldn't have got that if you thought of this another way. If you thought this was the median here, you would have said it was 30, which is a complete misinterpretation of this graph. So you got to put them in order, and you got to find the middle. So the answer should be B, and I will confirm. I'm just looking on the clave. Yes. All right. Yes. Very good. Okay, we keep going. Let's do the next one. Oh, these ones are messy. Interquartile range. Okay, so what is the interquartile range for this data set? It's already in order, so that's helpful. All we need to know is the middle, like, well, how many observations are there? So they don't tell us, we have to count them, right? So let's count. I'm going to count. What you can do is you can write down frequencies in case you throw off your count. So you can do something like that, and you can say there's 1, and then you could say there's 1, just like we were reading before, and then cumulatively, which is the most important information, cumulatively adding them up, there's 1, so then 1, and then there's 2, 3, 4, 5, 6, 7, 8. So the cumulatively, this is 8, but by frequency this is 7 and this is 1, right? And let's do that. Let's do the 2 columns. So then 1, 2, 3, 4, 5, 6. And it's easier to see now because we have something there. So 6. But if you add 8, you take 8 and you add 6, you get 14. So we have a total of 14. And then in this one we have 1, 2, 3, 4, 5. So we're going to write that down. And then add those, which is 19. And then here you have 3 for a total of 21. Did I make any mistakes? Oh, I did it wrong. 20. What am I doing? 22, you're right. 22. It's so funny. Okay, see, I need you guys as much as you need me. So we have 22. And so the median where n is 22, the median is at n plus 1 over 2. So that's 23 divided by 2, which is 11.5, right? So I have to go between 11 and 12 to find my median. So so this is 8 up here. So 9, 10, 11, and 12. So between here and here is the median. Let's do that again. So that makes 8, 9, 10, 11, 12. So between these two, so what is between these two? That's going to be 54 and 55. So it's going to be 54.5 is the median. So this equals is not a right thing to write. I'm going to just fix that because that bothers me. This should be like this, right? The median is found where n plus 1 divided by 2, that observation. It's not that m equals that. M is actually equal to 54.5. Now I don't need that number, but that number divides the data in half. I don't use either. I don't use that number, but I divide the data that way into two halves, where I have 11 on one side and 11 on the other. So I can clean this up. Let me clean this up. Let me I want to erase just this. That's all. It's going to erase too much. No, I don't want to do that. Okay, well, trust that you understand what I'm saying, that we divide right here. And that will make the data split in half. And then there's going to be 11 on one side, 11 on the other, so those are odd numbers. Again, we can use the rule. So we're going to use the rule that n plus 1 divided by 2 is where we want to be, but now use n of 11, so that's 12 divided by 2, which is 6. At the 6th observation, so that's going to be 1, 2, 3, 4, 5, 6. That's where let me do that again. 1, 2, 3, 4, 1, 2, 3, 4, 5. That's the 6th observation here, right? And then there's going to be 6 more to the right of it. 1, 2, 3, 4, 5. Oops. Did I miss it? 1, 2, 3. 1, 2, 3, 4, 5. So sorry, 5, because this is a 6, so there's 5. 1, 2, 3, 4, 5. Right. And then we're going to do 6 this way. 1, 2, 3, 4, 5, 6. So it's going to be at 65. Okay, so this is what we found. We found that Q1 is this. Q1 is 47. And Q3 is 65. Any objections? Any objections? 65 minus 47 is the IQR, so there's one more step. They want you to find the IQR. The IQR And what is that? It's 18. So the answer should be D. Should be D for number 8. Yep. All right. Practice, practice, practice. Should I do another one? How did I get Q3? Q3, I went from here and counted the same 6, just like here, because this is the middle of the first half and it's also the middle observation of the second half. So I start here. 1, 2, 3, 4, 5, 6. So I did 1, 2, 3, 4, 5, 6 to get that one, and then in the second half I start 1, 2, 3, 4, 5, 6, 65. Okay, well, review that. Ask me if you still have problems. Should I do another one? I will leave 9 for you to do. 10, 11. We did 11. Maybe I'll do 10. So yeah, the last several questions are about sampling and design. Make sure you read those. So let's here, let me try these ones. Okay. Let's try these ones here, because these look weird. Okay, this one's a lot of work. I mean, I can do it. Let's just see. You have just a bunch of rectangles. What is the principle that we're testing you on here? The principle is that the area of a density curve should be equal to 1. So this is H, this is 2H, this is 3H. The question is, what is H? So you got to make an expression that makes sense, understanding not only if the area of the total thing is 1, but any box or any rectangle in this area is calculated as a measure of height times width. So you could cut this up into do it this way. 3 boxes and make it an equation. So the 3 boxes between here and here, between 11 and minus 2, are how many values? It's 11, so let me mark 0 to help you. Here's 0. So 11. Sorry, that's not 0. Oh, I marked in the wrong place. Let's do 0 is this one. Okay, so you see that between here and here is 11, and then 12, 13, 14. Okay, so there's 14. The whole width here is 14. The way to calculate that, always to get a width, would be to take the higher value minus the lower value. So that's upper versus, minus lower. Upper minus lower. So you take 11 minus -3, and that's how I also can calculate 14. So that's 14. So 14 times the height of h plus you need the area between here and here times h. And you need the area between here and here times h, or maybe, yeah, no, you want to go all the way up, right? Let me erase that one. But let me just shade it in. So you're going to calculate this. No, you don't have to calculate that because we just did this one. So we just did this one. If we do all of this, then you just need to calculate this, and then you need to calculate this. And you make an expression, and all of that expression should be 1. So 14 times h is that piece, and this piece is, let's do the same thing as before, 3 minus -3. So they're all a bunch of w's, so width is 3 minus -3, which is 3 plus 3, which is 6. So this one here is going to be a width of 6 times a height of h, because they're all the same, right? From h to 2h is an h. And then here's one more h just for this area here, and this is a length of 2. So it's going to be 2 times h. So what do you have? You have 14 times h, 6 times h, and 2 times h. And you add them all together, and it's 22 h's, and that has to be 1. You get it? Did you guys leave me? A bunch of you left. So you have, just to repeat, we're using the principle that the area of a box is width times height, or height times width. So I'm doing width is 14, height is h. Width is 6 for here, height is h. Width is 2 here, and the height is h. So you have 22 h's are equal to 1, so h is 1 over 22, which is the best answer if you plug it in. The best answer is C. The second is, uh-oh, did I rate it wrong? Thank you. So many mistakes. This is not minus. This is minus 2. She's right. And so it's 5. So this is 5. And so the answer is 21. H equals 1. So H equals 1 divided by 21. It's the same answer. Isn't that great? $14, not 13. The first one is minus 2. Minus 2 and 13. See, you guys, this is the greatest thing. You're better than me at this. Keep on making little mistakes. So that's 13. And so it's 20. So H is 1 over 20, which is still the same answer. You see, it doesn't really matter. I can make so many mistakes. Still the same answer. Okay. I'm sorry, but you guys should clean it up. I didn't think I would be solving these things completely. I thought I'd just answer some of your questions, but it looks like I had to solve them completely. And you can appreciate the videos I edited took me a long time because it's so easy to make mistakes and it's so awkward with this screen and not the right stylus. All right, it's always the same answer because it's generally in the right ballpark. Any more? Oh, the students last semester, I didn't like this one. Oh, what happened? How did that get detached? I don't know. I have to stick it. And then, okay. What about 34? It's all so dramatic. What about 34? What's your best answer? Which region has the largest area? See, I make you feel less bad because I make so many mistakes. When I solve these problems on a test, I would just, when I was taking these courses way back when, I would solve the problems twice or 3 times and I was different ways each time to see that I get the same answer. Okay, so what is the best answer? $34. So how are you going to figure this out? E, Isaac says. Okay, so this is a normal distribution. That's what we're told. In a normal distribution, we know about these regions, right? We know that the white one is, well, it's half of 68, because between here and here is 68. So this is 32. So I can make a note that this is 32. 34, sorry. 34, because it's half of 68. And then what's the black? The black, it extends out. The black region extends out between between two standard deviations. This is supposed to be 95, but minus the inside, that's 68. So 95 minus 68 leaves the black region, which is how much? It's 27 for the black. And what else? So 27, the gray is 34. And what else do they give us? Oh my goodness. My paper's gone. Let's see. So the gray region, 34, the two black combined are 27, and depends on the value of mu, nope, and depends on mu, sigma, nope, depends on both mu and sigma, nope. No matter what the mu and sigma are, because it's normal, all the normals will have these properties. So the winner is, the largest area is the gray region, A. Yes, the answer is A. All right. One more. Which one do you want me to do? The normal problems are straightforward, I think. You should practice with the videos to do the normal problems. So which one would you like me to do? I'm thinking I'm going to leave you. I'm going to do one more. I'm going to leave you. I'm going to leave you to finish this. I know it's Friday night, but you're going nowhere. Finish this to the best of your ability and send me a list of the problems that you didn't understand. And then maybe I'll make a presentation for you this weekend. I'll let you know. Otherwise, I'll see you on Monday. So are there any other problems, or do you want to get going? Only 6 of you here. I'll do this one. No one said anything. I'll do number 10. Number 10. We measure the heights of a random sample of 5 men. The sample mean and standard deviation are calculated to be 175 and 6.27. A 6th man whose height is 175 is added to the sample. What is the new standard deviation of heights for the sample of men? So, looks like you have to think about what it means to the standard deviation if you add someone. So you're adding an additional person. You're adding an additional person, but the person's height is the same as the average. Will that change the standard deviation? I'm tempted to leave it for you. All right, I am waiting for you guys to say something. Have you said something to me? Does it change? Does it stay the same? Well, think about it. What's the formula for the standard deviation? Remember, this is a sample, right? So the sample formula is okay, so that's the formula for the sample standard deviation. Now, you've added an observation that's the same as the mean. And the n is going to change. If your observation is the same as the mean, you're adding nothing, right? You're adding nothing to the total. You're adding nothing to the total because this would be x bar minus x bar, the 75 minus 75. So I'm just adding somebody that doesn't affect, doesn't add anything to the sum. However, it's going to add to the denominator. So because it reinforces the mean, it's another value that's just like the mean, and the standard deviation is a measure of deviation from the mean, right? That means that the overall standard deviation should go down. So by how much are we talking? So, do you guys know how to do this? I know how to do this, but do you have any idea to get the actual answer? So it's similar to what we did with the mean question. We're going to work with the totals rather than the averages. In this case, rather than the standard deviation, work with the totals. So for the old standard deviation, 5 people gave you a standard deviation, going back here, 5 people gave you a standard deviation of 6.27. And then this total, or sum, right, that's what this is divided by n minus 1, so that would have been 4. Do you guys see where I'm going with this? So then the total, you could actually figure it out for the original case. Now when you add the 6th person, the total doesn't change. So you just got to take the total and divide by 5. Get it? And it should go down because you're dividing by 5 now, not 4. Okay, so that's the total, multiplying this by this. And so now I take that and I divide that not by 4, I divide it by 5, because I'll make it a little. So these are the old calculations. And the new calculations are going to be total so like this is like the new, or S star, and this is, oh, I forgot the, by the way, I forgot the square root. Let me put that in so no one's confused. Now that really screws things up, doesn't it? That's squared, and that's square root, so I have to first square this. So this is not, this is 6.27. So many mistakes. I just want to erase here. Ugh. All right, I'm going to scratch it out. This is not the total. Total is going to be S 6.27 squared times 4. That will be the total. You still watching me? So the total, if I do this, I need to layer this. So total was equal to 6.27 square times 4. That's the original total. And then you're going to take that over here into the new total to find out so messy. I'm giving you tips. Just take these as tips. This is a point. So the total is the same before and after because you're just adding the average. You're adding nothing. So the total will remain the same. So you can put that in there. And then you can divide by the new sample size, which is 6 minus 1, which is 5, and you'll find the new standard deviation, which was the original question. What do you get? .27 squared times 4 divided by 5. I did something wrong. Oh yeah, square root. 5.61. The answer is C. Yes, Delia, very good. Yes, very good. Okay, so you guys, we've done like some really challenging problems, and trust me, the other exams will have similar problems. Once you do one, it just repeats, okay? Practice it. If you notice, the instructions of these exams are that I let the students pick from the set of 40 questions, they only answered 30. I think I'll use the same technique with you. Just stay organized, be neater than me with your work, and after you do the test, upload your handwritten work, okay? So send me a list of the problems you'd like me to try or present or resolve. Okay, send me a quick email or a text, and otherwise I will see you on Monday. Okay? Thank you for watching, you 6 or so people, and the rest of you who are watching later, just forward all my you can forward, you can run this on a higher speed or faster speed, so it's not so long. Otherwise, you're watching for almost 2 hours. So have a good weekend under the circumstances. Rest. And we will be in touch, okay? Take care.